Welcome back to this channel. In this lesson, we want to discuss arithmetic mean and the sum of nth term of an arithmetic progression. So at the end of this lesson, you should be able to understand or calculate arithmetic mean, and you should be able to calculate the sum of nth term of an arithmetic series. So let us continue. So when we talk of arithmetic mean of two numbers, so consider two numbers. Consider the number P and R. Okay, P and R. So let the arithmetic mean, I'll call it AM. Let the arithmetic mean of this number equals to Q. Okay, let's call it Q. Q. So then if Q is the arithmetic mean, then we have P, Q, and R are arithmetic progression, forms an arithmetic progression. So then if P, Q, and R forms an AP, you can find the common difference. So therefore, common difference D implied D equals to Q minus P and D equals to R minus Q. Okay, so call this 1, call this 2. If you equate equation 1 and 2, you have R minus Q equals to Q minus P. Okay, so bringing Q to Q and R to R, I have R plus P. Okay, R plus P equals to Q plus Q, and then R plus P equals to 2Q. Dividing both sides by 2, so we are going to have that Q equals to R plus P all over 2. So this formula, guys, is called the arithmetic mean of an arithmetic progression AP. So this is arithmetic mean, and this is how to find arithmetic mean. So if you can find arithmetic mean, you can insert a number of terms between the terms of an AP. So let's consider this example. Find the arithmetic mean of 10 and 25. Okay, so solution. If we are to solve this, so we say let the arithmetic mean equals to, let's say, number B. Then 10, B, and 25 forms an AP. Okay, and then we can find the common difference. Common difference is B minus 10, and common difference is also 25 minus B. So call this equation 1, equation 2. So if you equate equation 1 and 2, you have B minus 10 equals to 25 minus B. So bring B together, B plus B equals to 25 plus 10. Okay, so 2B equals to 35. So if you divide both sides by 2, you're going to have B equals to 17.5. So the arithmetic mean of this number is 17.5. So the AM is 17.5. Okay. Yeah. So this is how to find AM. There are other things we can also do with AM. Example 2. Insert 3 AM between 19 and 35. So insert 3 arithmetic means between 19 and 35. So let us see how it goes. So let the arithmetic means equals to A, B, C. So that means A, 19, A, B, C, and 35 forms an AP. Okay, so we can find the common difference. D equals to A minus 19. Okay, yeah, D equals to A minus 19, of course, and we have the first term equals to 19, and we have the last term equals to 35. And you know the formula for calculating the last term, which is A plus n minus 1 bracket D. And of course, the number of terms in this sequence, 1, 2, 3, 4, 5, n equals to 5. So U5 equals to A plus 4D, which is 35. So, and of course, we know A to be this, so we can substitute that A plus 4D equals to 35. That will give us 19 plus 4D equals to 35. So 4D equals to 35 minus 19. 4D equal to 1 plus 15. 4D equals to 16. So if you divide both sides by 4, we have 4 and 16 equals to 4. So D equals to 4. So having gotten D to be equal to 4, of course, yeah. So we can find A from those formulas given. So you know D equals to A minus 19. So that implies 4 equals to A minus 19. So A minus 19 equals to 4. So A equals to 19 plus 4. And A equals to 23. So since D equals to 4, so B will be A plus D, which is 23 plus 4, which is 27, and C equals to B plus D, which is 27 plus 4, which is 31. So we have now found the terms A to be 23, B to be 27, C to be 31. Therefore, the sequence is 8, 19, 23, 27, 31, and 35. So we have inserted 3 arithmetic sequences between 19 and 35 using the method of arithmetic mean. Alright guys, so let us continue to sum of nth term of an arithmetic progression. So it is possible to use the formula of the nth term un equals to a plus n minus 1 bracket d to calculate the sum of nth term of an arithmetic progression. Remember, series is the addition of sequence. So when you have a series, you also have arithmetic series. So how do we calculate the sum of the nth terms of an arithmetic series? Okay. So the formula for the sum, so the sum of nth term of an AP is given as Sn equals to n all over 2 into A plus L, or Xn equals to n over 2 bracket 2A plus n minus 1 bracket d. Okay, where n equals the number of terms. Okay, A is the first term, L is the last term, and of course D is the common difference. Okay, so with this formula we can calculate the nth term of an AP. But before we continue to solving examples, let us prove this formula. How do we come about this formula? Proof. So let Sn equals to A first term plus second term plus third term, okay, plus up to second to the last term, let's say L minus 2D plus L minus D second to the last term and plus the last term. Okay, so if we invert this formula, you can invert this formula to give you L plus L minus D plus L minus 2D plus dot plus A plus 2D plus A plus D plus A. So if you, let's call this equation 1, call this equation 2. So if you add equation 1 and 2 together, we have 2Sn equals to A plus L. Here, D will cancel D, we have A plus L. Here, D will cancel D, we have A plus L. So you continue like that to here, you still have A plus L plus A plus L plus A plus L. Okay, so if you add it up to n, you have n into A plus L. Okay, so dividing both sides by 2, you divide by 2, you have Sn equals to n over 2 bracket A plus L, and that gives us formula 1. Now substituting L equals to A plus n minus 1 bracket D, which is the formula, we have xn. We obtain the second formula, xn equals to A n all over 2. That will give us 2A plus n minus 1 bracket D, and then we arrive at the formula. Okay, so this is how to prove the formula for the nth term of an AP, and then you are done. So let us consider examples. Example 1. Find the sum of this series 3 plus 7 plus 11 plus 15 up to 10 terms. So here for A, n equals to 10, okay, A equals to 3. The common difference is 7 minus 3, which is 4. So we can find the Sn. So we don't know the last term, so we use the second formula, n over 2. Always state your formulas into bracket n minus 1 bracket D. So this is 4 over 2. So therefore S10, we are looking for the sum of n. So this is n10 equals to 10 over 2 bracket 2A plus 10 minus 1 bracket D, which is 4. So we can solve that to be 5. 2 by 5, 6 plus 9 times 4, which is 5 into 6 plus 36, and that will give us 5 times 42, which is times 2, which is 10, carry on, times 4, 20 to 10. So S10 equals to 210. So we can do B as well, same way. So for B, A is 40. Common difference is 35 minus 40, which is minus 5, up to 15. The nth term, the number of terms is 15. So we use the second formula, Sn equals to n over 2 bracket 2A plus n minus 1 bracket D. Do all those things. So sum of 15, we have S15 equals to 15 over 2 bracket 2 times A 40 plus n minus 1, 15 minus 1 bracket D, which is minus 4. So this is 15 over 2 bracket 2 times 40, which is 80 plus 14 times minus 5, and this is 15 over 2 into 80 minus 5 times 4. 20 carry 2 times 1, this is 70. So we have 15 over 2 multiplied by 80 minus 70, which is 10 over 1. So 2 here, 1, 2 here, 4. And 15 times 4, that is 75. So the answer here is 75. An arithmetic series has 12 terms. The first term is 10 and the last term is 65. Find the sum of the series. An arithmetic series has 12 terms. The first term is 10 and the last term is 65. Find the sum of the series. So according to what we have there, the number of term is 12. Okay, the first term A is 10 and the last term L is 65. Find the sum of the series. So we can use the second formula. Sn equals to n over 2 bracket A plus L. Yeah, that is the shortest formula to use. So we have S12 equals to 12 over 2 into bracket A plus 65. So this is 6 multiplied by 75. 6 times 5 is 30 by 3, 6 times 7, 42 plus 3, 45. So the S12 is 450. In an arithmetic progression, the 8th term is 39 and the 4th term is 19. Find the first and the sum of the first 12 terms. So write down the formula as usual. Formula for the nth term, un equals to a plus n minus 1 bracket d. Okay, so we have then the 8th term. So we have u8 equals to a plus 7d, and that a plus 7d equals to 39. Call this equation 1. The 4th term, u4 equals to a plus 3d, and that a plus 3d equal to 19. Call this equation 2. So before we can do anything, we have to find a and d. So from equation 1 and 2, solving simultaneously by the method of elimination and subtracting 2 from 1, we have 70 minus 3d equals to 4d. 39 minus 19, we have 20. Divide both sides by 4. So we have d equals to 5. Okay. Now substituting 5 in equation 2 to find a, we have a plus 3d equals to 19. So a plus 3 times 5 equals to 19. So a equals to 19 minus 2 times 5, which is 15. A equals to 4. So we have found one of the questions. So first term equals to 4. Now the sum of the first 12 term. So sum of the first 12 term, we write down our formula Fn equal to, do we know the last term? No. Yeah, we know the common difference. We know the common difference. So we use the second formula into 2a plus n minus 1 bracket d. Okay, so of course we have all the things we needed. S12, n equals to 12, a equals to 4, and d equals to 5. So if you substitute all of this into the formula, we have S12 equals to 12 all over 2 into bracket 2 times 4 plus 12 minus 1 bracket d, which is 5. So we can have that to be 6 into 8 plus 11 times 5, which is 6 into 8 plus 55, which is 6 times 58, 60, 63. I think so. So 6 times 3 will give us 18, carry 1, 6 times 6, 36, plus 1, 37. So therefore sum of the first 12 term is 378. Now the 20th term of an arithmetic progression is minus 41. and the sum of the first 20 terms is minus 440. Work out the sum of the first 10 terms. So this is a lot of work. Let us go step by step. Start from the formula UN equals to a plus n minus 1 bracket d. Okay, the 20th term, so we have u20 equals to a plus 19d, and that a plus 19d equals to minus 41. Call this equation 1, and the sum of the first 20th term is minus 440. So we have S20. Let's write the formula of Sn equals to n over 2 bracket 2a plus n minus 1 bracket d. So S20 equals to 20 over 2 into 2a plus 19d. So this is 10 into 2a plus 19d, and that from the quotient 10 into 2a plus 19d equal to minus 440. So if we divide this side by 10, we have 2a plus 19d equals to minus 44. We call this equation 2. Okay, so solving the equation simultaneously. Equation 1 is a plus 19d equals to minus 41. Equation 2 is 2a. Okay, so we can multiply equation 1 by 2 to have 2a plus 38d equals to minus 81. Let's call this equation 3. So subtracting equation 2 from 3. Let's see, equation 3 minus 2. We have 3 minus 2 will be 13a minus then we have 19d minus 81 minus 44. So minus 81 minus 44, that will be plus 11 minus 4 plus 7. This one is 7 minus 7 plus 4, we have 37. So this is 1. So this is equal to minus 37, of course. So dividing both side by 19, so this will go here, this will go here, should be 3 or 2. Let's check very well. 3 times 9. 440, of course. Multiply, oh sure. This is 82. 82. 82, so this is 38. So this is minus 38. So 19 and 38 we have minus 2. So therefore d equals to minus 2, and using any of the equation to find a, let's use equation 1. So we have a plus 19 times minus 2 equals to minus 41. So a equals to minus 41 plus 38. So a equals to 2 plus 1 equals to 3. So therefore a equals to 3, d equals to minus 2 is what we have obtained from the given information. Then we are asked to work out the sum of the first 10 terms. So we are asked to work out the sum of the first 10 terms. So n equals to 10, okay, a equals to 3, and d equals to minus 2. So Sn, so S10 will be 10 over 2 into 2 times 3 plus 10 minus 1 bracket minus 2d. So this is 5 into 6 plus 9 times minus 2. So this is 5 into 6 minus 18. So this is 5 into minus 12, and this is minus 60. So S10 is minus 60. in an arithmetic progression. So this is the last question. In an arithmetic progression, the sum of the first term and the fifth term is 18. The fifth term is 6 more than the third term. Find the sum of the first 12 terms. So let's do this together. So let's write the formula of nth term, a plus n minus 1 bracket d. Okay. So the first term and the fifth term, the sum of the first term and the fifth term is 18. So first term u1 is a, or fifth term u5 is a plus 4d. So sum a plus 4d equals to 18. So that means 2a plus 4d equals to 18. So if we factor out 2, we have a plus 2d equals to 9 times 2. So dividing both sides by 2, that will give us a plus 2d equals to 9. Let's call this equation 1. The fifth term is 6 more than the third term. So u3 is a plus 2d and u5 is a plus 4d. Now the fifth term is 6 more than the third term, that is a plus 4d equals to a plus 2d plus 6. Okay, so we can collect like sign over here, equals to minus a minus 2d equals to 6. So a and a will cancel, so we have 2d equals to 6. Dividing both sides by 2, we have d equals to 3. So substituting this in equation 1, that will give us a plus 2d equals to 9. So a plus 2 times 3 equals to 9. So a plus 6 equals to 9. So a equals to 9 minus 6, which is 3. So therefore a equals to 3. So we have d and we have a. Now find the sum of the first 12 terms. So we can now use the formula to find the sum of the first 12 terms. So we have Sn equals to n over 2 to 2a plus n minus 1 bracket d. So first 12 times 12, a equals to that, d equals to this from the formula. We have d equals to 3, a equals to 3. So substituting into the formula, we have x12 equals to 12 over 2 bracket 2 times 3 plus 12 minus 1 bracket 3. So open the bracket and simplify. We have 6 plus 11 times 3, which is 6, or 6 plus 33, and this is 6 plus 36, 39. So if we add 6 to 39, 6 times 39, of course. So this is 6 into 30 plus 9. That will give us 180 plus 6 times 9, 54. So therefore S12 equals to 4, 3, 2. So S12 equals to 234. So guys, this is how to find the sum of nth term and how to solve problems using the sum of n terms. And know the formula and write down what you are given, then sort out what you are asked to find, and then you'll be on your way out. Bye.